Okay, welcome back. This is Chapter 9. Chapter 9 is on subnetting. So subnetting is not a very complex topic, and thankfully this is kind of a short chapter. It's all about subdividing your IP address space into smaller chunks. Okay, so let's look at the learning objectives on page 299. And they say, well, what a subnet, what are subnets and why are they useful? What are the factors that determine the size? What a subnet mask is, what the relationship between the subnet mask and the size, and how to compute the subnet mask. So on page 299, they try to answer the first question on why. So the whole idea is that IP, whether it be v4 or the new v6, they give you a chunk of IP addresses. Once they do that, you're allowed to go in and just use it just the way they gave it to you. That's fine. Or you can say, I want to split that in half. I want to have, let's say I've got 2 buildings on my campus. So I just want to split it in half and say this half of the IP addresses go to that building and this half of the IP addresses go to that building. It's your choice. So the key to this is those IP addresses belong to you and you can do whatever the heck you want. You can leave them alone. Or you can subdivide them into 2, 4, 8, a gazillion, however many you want. And you don't have to ask permission or tell anyone, because they're your IP addresses. Okay. They talk about the business motivations of why you want to do this. And they show a diagram, kind of a before diagram. And so let's imagine that you had a university campus and all you had was one giant network, no subnets, and you just had DHCP turned on. So whatever machine woke up first got the first IP address. Okay, so there's no rhyme or reason to it. So here we are. These guys are all 131.247.0, and then this machine woke up first, and then that one, and then this one, and then this one. And, it's just kind of a random kind of a thing. Now, is there something wrong with this? Well, no. But what if you're the business school, and you want to make sure that all the machines in the business area have the exact same piece of software on them, and you want to treat them differently. In other words, you're in charge of this tiny little section, and so you want to be able to manage these PCs when somebody else is managing these. And trust me, the lab workstations in engineering is not going to have the same kind of software on it as the folks in the hospital, right? Or the folks in the library, or the folks in the business school. These are radically different uses for these machines, so it'd be kind of dumb to treat them all the same. So from a management perspective, it makes a heck of a lot of sense to kind of break these things up so you can identify them. So here's the after picture. The after picture is they decided to break these things up into the 4 sections, 4 regions, or whatever you want to call it. So the hospital has a 131.247.5, library has 1, engineering has 6, and business has 2. So they just broke it up into 4 different subnets. They took the IP address space that was given to them, chop it up into 4, and so now you can manage the machines better because you know which ones belong to you. Because most likely the people in the lab don't have anything to do with the machines over here and vice versa. Okay, so administrative and management responsibility, that's a good reason why you'd want to do this. Perhaps there's a security requirement. Perhaps these guys have some special security on them, or the hospital has special security that you really don't want to burden the rest of the system with. So, very granular, surgical approach to how you apply software policies or security or software. The next one basically is kind of a weird one. They talk about how this makes it easier to diagnose problems. If, for example, I've got a machine in here that's acting up, it basically means that the misbehaving machine is only going to affect a small area. Here, if I have a misbehaving machine, it's going to affect the entire university. So the smaller you make the areas, the more likely it is you're going to be able to control a problem and maybe go find and fix it so it doesn't spread, so to speak. So a misconfigured machine or misbehaving machine is not quite so damning. On page 302, they'll talk about the technical motivations. So from a technical perspective, how many machines can I actually have on a single network? I mean, can I have 3,000 or 4,000 machines on a Ethernet network? No. The standard for a single network. The standard is 1,000, and trust me, that is not anywhere near possible. That's just a fictitious number that somebody made up. 1,000, yeah, right. About 250 is about the absolute max you can have before performance craters, and about 100 is what the optimal max. How's that for a strange term? That when you're designing a network, no more than 100 machines per subnet if you're using an Ethernet subnet. So if I have 400 machines, minimum I should have about 4 subnets, because I don't want to exceed 100 machines in a subnet if I can get away with it. Okay, so here's another example of this, looking at it from the perspective of a router. So we have a giant router in the middle of the campus, and we're sending frames to this particular subnet, which has an address range, and this particular subnet, which has an address range. So basically what we've done is we've taken, so a key takeaway from this is router, subnet. Those guys are combined together. Anytime I create a subnet, I have to have a router. Okay. Okay, so all subnets require a router. All right, cool. So each one of these little subnets now basically have to have their own support services. For example, you would typically have a DHCP server in each one of these sections. Well, why? Well, because they're handing out different addresses. Over here, I'm handing out addresses in the range of 131.247.1. Over here, I'm handing out addresses in 131.247.5. Well, if I'm handing out different addresses, I probably need to have different DHCP servers in each one of these subnets. The other thing is, let's say one of these engineering machines wants to talk to another engineering machine inside the same subnet. Wouldn't it be kind of cool if I had my own DNS server inside each one of these guys, so that the machines could resolve their names inside without having to go all the way back up to ask, well, who the heck is machine number 42? Well, what if it could be handled locally? Okay, now that's not necessarily a hard and fast rule. There are some ways you can get it. There is ways that you can configure a DHCP server to have one to hand out different range of machines. It's not very normal, but it's happening. And DNS servers, yeah, there are ways you can set up a DNS server so that, yes, I'll take requests from anybody. But I'm just saying, if you're trying to make things very efficient, and you put all those support services in each one of these guys. So this is not a very good description of why. So I'm going to dig a lot deeper into the why part, which is not in the book. Let's start over. So here's a good way of describing it. Let's say you've got 3 kids in school, and you're getting ready to build a house. So you're talking to the developer, and you say, okay, I need to build me a house. And the developer's going to say, well, how many bedrooms do you need? You're going to think, I got me and my spouse, and I've got 3 kids. How about 4 bedrooms? Is that complex? Because you want to segregate the children from each other to have their own space, their own little world, their own little management, right? It's not complicated. This concept of how many subnets to build, how many departments do you have? If I got 6 departments, okay, I'll have 6 subnets. It's not rocket surgery. Okay. So each subnet basically needs a router. Why? Why do I need a router for every subnet? Well, anytime you have a separate network, in order to get 2 networks to talk together, you must have a router. It doesn't matter if it's between 2 subnets inside the same network. That's not relevant. Anytime you have differences. So I have an Ethernet chunk over here and an Ethernet chunk over here. Now, is it because they're completely separate networks, or the same network and subnetted? Don't matter. Don't care. It's the fact that they're different, and so therefore I need a router to make that happen. What about segregating traffic? Let's say, for example, that I have 2 machines in this environment over here that talk back and forth to each other a lot. And I mean an awful lot. Wouldn't it be kind of make a lot of sense to go ahead and put those guys on a separate subnet? Consider the alternative. Let's go back one. Let's say these two machines are talking to each other a lot. And let's say, okay, hypothetically, let's say that they're consuming 50% of the entire bandwidth of the entire network. These two machines right here. Well, over here, everyone gets affected by the fact that these two guys are chatty. So the machines in the hospital are slowed. Machines in the library are slowed down. And the machines in the business schools are slowed down. All because these two guys are chatting. Over here, these two guys are chatting. Yes, the machines in the engineering lab definitely will be affected, but it'll have no effect on the library, and no effect on the hospital, and no effect on the business school. So yeah, now it's beginning to make sense. So let's say I have two machines that routinely talk to each other. Wouldn't it make sense to physically, if you had a kind of a hodgepodge thing like this, maybe this guy over here and this guy over here often talk to each other, and they talk an awful lot. Wouldn't it make sense to move those people into the same subnet? So sometimes you build the subnet around a physical thing, like a building. Sometimes you build it around organizational, like you have a branch or a building, some sort of an organizational structure. Sometimes you build subnets strictly to do with traffic patterns. I have a distinct traffic pattern that occurs over here, and a distinct pattern that goes over here. So I've given you three things, okay? Physical, organizational, and traffic. Those are the three reasons why you might want to do this. Okay, so let's go back to this guy one more time. All right, so each one of these guys is a separate Ethernet segment now. So what's unique about an Ethernet segment? Well, broadcasts, right? A broadcast from here doesn't get transmitted through the router. So once again, probably should just leave it on this page. Without any subnets, when this guy broadcasts, everyone in the entire university hears it. Over here, when this guy broadcasts, only the machines in the library hear it, which is probably what you had in mind. So broadcasts, cutting down on broadcasts. So will breaking this campus up into 4 sections, will that actually speed up the network? Yeah. Yeah, it will. It will actually make things go faster because of all the broadcasts, because of the chatty machines that dominate the traffic pattern. There's lots of reasons why this will speed things up. Now, okay, I'll admit, if you're a small mom and pop and you're nowhere near saturation, let's say, you're probably 20 or 30% of using the entire bandwidth of the network. Okay, and you've got, I don't know, 40 machines. Okay, breaking those into two subnets of 20 apiece probably won't get you anything because you weren't anywhere near saturation. But the big boys, where you have 100 or so machines, yeah, you're going to see tremendous. You're going to see like, whoa, what happened? This network sped up. Well, we broke off the noisy people and put them in their own subnet. Yeah, okay, good stuff. So here's another interesting question. So one question is, what about broadcast and collision domains? Yeah, collision domain. That means the way that these two machines should talk and detect collisions, that occurs inside a single segment. And so collisions are better and broadcasts are better. So it helps Ethernet in lots of ways because I don't have to listen to everybody else's broadcast. Plus, makes collisions better, so I'm much better off, much more efficient network now. I can speed things up because I don't have to deal with other people's traffic in my section. And the third one would be, what if I wanted to apply some different security over here that was kind of different? For example, I didn't want any traffic from this subnet at all going over here to that subnet. That'd be a pretty cool way to do it. Okay, I'm going to pause here for just a minute, and we'll be back.